Third one, probability of A union B is equals to probability of A plus probability of B if A intersection B is null set. Is the font visible? Okay. Now coming to joint probability. So joint probability comes from the Venn diagram. This is A, this is B. This is A intersection B or AB. So the probability of this one is joint probability. Okay. So the probability of A union B formula is this one. Okay. If A intersection B is null set, then probability of A union B is equals to probability of A plus probability of B. Just now we have seen this in axioms. Now the probability of A union B, it's a P of A plus P of B minus P of A intersection B. This is less than or equals to summation of individual probabilities. This is equal when A intersection B is null set. If A intersection B is not null set, this inequality comes into picture. Less than comes into picture. Next, conditional probability. The conditional probability can be represented as probability of A slash. We read that slash as given. You have to read it as A given B. A is one event, B is another event. B is already happened event. B is already happened event. A is a current event or present event. You understand? Probability of A given B. So it gives a dependency. Probability of current event given already happened event. So the formula for this one is probability of A given B is equals to probability of A intersection B all divided by probability of B. We can also write in this in other ways. Probability of B given A is equals to probability of A intersection B over probability of A.
Excuse me, sir.
Yes.
Sir, your audio is not clear, sir. We are getting disturbances in middle.
Wait. I'll leave and join again. Is it okay now?
Yes, sir.
Thank you. Now, if you clearly observe in these two formulas, A given B or B given A, the numerator is joint probability. Joint probability. Now, if you write the joint probability formula, probability of A intersection B is, you can write in two ways. Probability of A given B times probability of B. This is also equals to probability of B given A times probability of A. Okay. And there is a one special condition. A and B are mutually exclusive. Mutually exclusive means A intersection B is null set. Then what is the probability of A intersection B? It's the probability of null set.
Zero.
What is the probability? Zero. So numerator is zero. So probability of A intersection B or B intersection A. Both are, sorry, probability of A given B or B given A. Both are zero if A and B are mutually exclusive. Next. See, A given B or B given A or A plus B, A union B, A intersection B, or A minus B, or A minus B, A given B, B given A. What are these? All these are events. For this, we apply probability. Okay. For this, we apply probability. So whenever you are applying probability on some events, there should be some axiom that has to follow axioms, right? So anyway, the probability is in between 0 and 1, right? It cannot be more than 1, it cannot be negative. The first one is satisfied, right? A probability of A given B or B given A, it is bounded by 0 and 1. Okay. And the second one is probability of sample space. Okay. Given B is always 1. Is always 1. And the third one, probability of A union C given B. It is equal to probability of A given B plus probability of C given B. If A intersection C is null set. This is axiom 1, axiom 2, third axiom for conditional probability. Okay. Did you see the handout in the Google Classroom?
Yes, sir.
Yeah. You just go through it. It's an overview. There are no problems. It's called handout because just overview is there. Whenever you have overview, you can rethink, you can apply those concepts on problems. Okay. See, let us solve one problem here. In a failed eye experiment, we shall determine conditional probability of the event. Excuse me. Echo is coming. In a failed eye experiment, we shall determine conditional probabilities of event F2, assuming that event even has already occurred. So in this one keyword has come. What is that? Fair die. When we call it a fair coin, fair die, can someone tell me?
All events has equal probability.
Yes, the probabilities are equally likely. Okay, events are equally likely. Okay, that means in case of coin, probability of heads is equals to probability of tail equals to 1 by 2. And in case of die, probability of
6.
probability of 2 and probability of phase 3, like that, up to probability of 6 is 1/6. In that case only we can call it as failed coin or failed die. Next, can someone tell me what is the event we have to find out in this? Event F2, we have to find the probability of event F2. Okay, and one condition is given. What is that condition? Event has already occurred. First let us write sample space. Can someone tell me what is the sample space for failed die experiment or a die experiment? 1, 2.
Sir, for every experiment, sample space is 1.
Probability is 1. I'm asking the sample space. Probability of sample space is always 1 for every experiment. So when you perform an experiment for the die, what are the outcomes? What are the possible outcomes? Maybe 1,
1,
maybe
2,
2,
3,
3,
4,
4, 5,
5,
6.
6.
So you put them in a set that is a sample space. Okay. And it is given that event. What are the even numbers in this event phases? F2,
1, 4, 2, 4, 6.
2, 4, 6. Out of this, he is asking that event F2, we have to find the conditional probability of the event F2.